here in section 12.3, we're going to bring together the ideas from 12.1 and 12.2 and a third idea that I'm going to show you right here. And we're going to put all those ideas together into one important key concept. So the third puzzle piece we need to get to this idea is a sort of a unifying idea that's probably never been brought together for you before. And this is a collection of ideas that you've been running into in different places in math, and they're all related to each other. So theoretically, you might have noticed that all of these things tied together. But in case you've never really realized this, what I'm pointing out is that when you're working with exponents, when you have a base of some sort with an exponent and an answer that it all comes out to be, that there are three numbers involved in that. There's the base, there's the exponent, and then there's the answer you get from the base and the exponent. And because there's three numbers there, that produces really three categories or three types of equations you could work with. The simplest type of equation would be what I call the A type, where you're trying to find A of those three numbers. And this is the one that you learn first, probably as early as elementary school. If you're working with something like 2 to the 5th, in elementary school they teach you to take 5 2's and multiply them together. So you would go 2 times 2 times 2 times 2 times 2, and you would get 32. But that doesn't mean that all A-type equations are easy. Some of them are pretty challenging. You probably didn't learn about negative exponents until pre-algebra, or maybe even algebra 1. Negative exponents make a reciprocal. So 9 to the negative 2, negative means it'll be 1 over something, and then 9 to the 2 is 81. You probably would not have done something like that in elementary school. And then fraction exponents, you probably don't see them until Algebra 2. This class may have been the first time you saw fraction exponents. So this one's going to be really tricky. You might want to pause the video and see if you get the right answer to this. So the negative means 1 over. The denominator of 3 means you're doing a third root, and the third root of 8 is 2. And then the exponent of 2 means you're going to square that, so you should get 1/4 for that altogether. So A-type equations aren't automatically easy types of equations. Some of them are easy and some of them are hard. B-type equations, same idea. Some of them are easy and some of them are really not easy. So this first type here, really, really simple. You probably could have answered that one back in elementary school. In fact, it's not even really an equation in a sense. It's mostly just a familiarity test. Do you know your perfect squares pretty well? If you know all the different perfect squares up to like 10 or 11 squared, you're supposed to recognize that that is 7 squared. Later on, after elementary school, as you get more and more sophisticated, you might eventually start to realize, hey, wait a sec, there's actually another answer to that. It could also be -7. But at first, you wouldn't have thought of the negative answer as a possibility. You would have just thought of the 7. Again, not all B-type equations are easy. Some of them are pretty tough, like this next one here. What do you think the answer is? See if you can check it. Pause the video, try an answer, see if it works, try another answer. Because of the negative exponent, what's going to work here is going to be 1/2. The negative will do a reciprocal, which will turn it into 1. And then the 5, 2 to the 5, will produce 32. And then there are ones like this third one here, which honestly, you really are not expected to be able to answer that by hand. I mean, if you try to do guess and check, you try 3, and 3 is too small. 3 squared is only 9. You try 4, and 4 is too big. 4 squared is 16. So it's somewhere between 3 and 4, and if you're really feeling ambitious, you might try decimals in between, but that's going to be a mess. So eventually, with enough algebra training, you will learn that the answer to a problem like this is actually easier than it appears. When you're not expected to be able to get a nice numeric answer in your head by just sort of reasoning it out, that's where we start to use this notation, this root symbol. But let me make a philosophical point here, and this is actually a really important philosophical point. This and this, the 10 equals blank squared and square root of 10, these two things, they really say the same thing. They don't actually say anything different. The only difference is the second one here looks like you've answered it, even though you really haven't answered it at all. It's sort of like if you ever watch any news channel and watch anybody interviewing any politician. You ask a politician a question, and they'll talk for 5 minutes and not actually answer the question. Same idea here. What number squared gives you 10? Well, the square root of 10. Okay, well, what does that symbol mean? That means a number that when you square it, you get 10, which is what I was just asking you to try to figure out. What number squared gives you 10? Well, it's the number that when you square it gives you. It's not an answer. It's just a rearrangement of the information in a format that looks like an answer. And then, realistically, what you would do is you would grab a calculator. You would make the calculator do the arithmetic of guessing and checking and giving you a decimal answer. Okay, and then there is a third type of equation, this one over here on the right. I mean, if you've got A and B, there's going to be C type equations also. And just like the other types, some of them are easy, some of them are hard, and some of them you can't really do by hand at all. So this first one here, you could totally do that one by hand. You just got to know how 10 to different exponents works, and it's really simple. Here, to get 10,000, that's 10 to the 4. 10 times 10 times 10 times 10, you get 10,000. Not really a very challenging one. Second one's a little more challenging, but I've given you some strong hints here today. There have been several problems we've done in which negative exponents were important, so that would probably give you a big hint that this exponent here better be negative. And then, to get to negative, to make a 1/4, you're going to have negative 2. And then this third one here, it's tricky, but it is doable by hand. And I've given you a hint before with this problem we did over here. Don't forget that fraction exponents are a thing. Here, to get from 16 to 8, I'm going to first do a 4th root. Denominator of 4 in the exponent means 4th root. 4th root of 16 is 2. And then I'll cube it. 2 cubed would give me 8. So that's a really fancy one. That's definitely pushing the limits of what we can do by hand. And then this last one here, totally not something you can do by hand. It's bigger than 3, because 2 to the 3 is 8. That's smaller than 10. It's not quite 4, because 2 to the 4 is 16. That's bigger than 10. And this is not the same as blank squared equals 10. This is 2 to the blank equals 10. Totally different question, so it's not like the answer is going to be the same as that other one. So just like what we did over here with B-type equations, with C-type equations, when you can't actually answer it, all we really do is we rearrange it to where it looks like an answer, where it doesn't contain any new information. It really says the exact same thing, but at least it'll look like we've answered the question. And the notation for this type of situation, it looks like this. Yes, that's right. These are logarithms. I'm sure you've heard about logarithms before. They tend to get a lot of hype. And if you've been sort of scared that they were going to eventually show up, that was really unfortunate, because logarithms are actually no big deal. We just did 3 of them. I mean, the first 3 problems up here, each one of those was a logarithm question. And we did them without really, well, the third one was kind of tough, but we did them. So what I'm going to do now is I'm going to take those first 3 and I'm going to rewrite them in logarithm notation just to show you what they look like. So this one here, compare with what we did there. The base, the b part of the exponent, that's what goes into the bottom of the logarithm notation. So that's like the 10 here. So this would be log with a base of 10. And then the answer that we wanted to get, that's what you're taking a logarithm of. Here we want an answer of 10,000. So we're taking a logarithm of 10,000. And then, remember, we already know what the answer comes out to be. We know that comes out to be 4. We did that a second ago, which means you already know that log base 10 of 10,000 is 4. That's what a logarithm is. Same idea here. 2 is the base. 1/4 is the answer we want to get, and the exponent that we figured out had to be there was -2. So log base 2 of 1/4 is -2. And then let's try this last one over here. 16 is the base. 8 is the thing we're taking the logarithm of, and this one was tricky. The answer came out to be a fraction. It was 3/4. So log base 8 of 16, or log base 16 of 8, sorry, I said it backwards. Log base 16 of 8 comes out to be 3/4. So with this idea in mind, that this is what a logarithm means, let's see if we can already do this logarithm here. You might want to pause the video, compare it with those 3 up there, think about what you're actually trying to figure out, and then see if you get the same answer I'm about to get. So, the 81 is the answer we're trying to get when we're done doing the exponent. The 3, that's the base of the exponent. And then the thing we're trying to figure out is what goes up there. So, just guess and check. 3 to the 2 is only 9. 3 to the 3 is 27. That's getting closer. 3 to the 4 gives you 81. That means log base 3 of 81 is 4. So, the ultimate point here of what we've done in this section is this, the definition of logarithmic functions. If you see log base b of a, and the answer comes out to be c, that means c was the exponent, b was the base, a was the answer you were trying to get. Some vocabulary I'm going to want you to learn that we're going to find really useful is the vocabulary, move the base to the other side. That's going to help us when we're doing our algebraic steps, working with equations. It's going to help us with graphing and so on. Now, in 12.3, there will be many problems that are just like what we've got on this screen here, where you're just working out a logarithm. But there are also going to be some problems that have to do with graphing logarithmic functions. And that's going to take a little bit of time to talk about. So that's going to be in the second video for 12.3. So if you've got this basic idea, you can just watch that one and focus on that. Or if you don't have any trouble learning the graphing, you can focus just on this stuff here. But there's going to be a second video specifically for graphing logarithmic functions.